Hello, today we're going to be looking at representing relations notes. So let's take a look at our first example. So it says express the following as a table, a graph, and a map. Then determine the domain and range. So a graph is where we have our x and y axis. Then we're going to also make a table for this. So a table, we have our x values, and then we have our y values. And then we have them set up just like this. This is known as a table. So this would be our table. Then for our map, we have our x values. We're going to list off all of our x values. Then we're going to list off all of our y values, making sure not to repeat any. And then we're going to draw arrows going from our x values to our y values. So let's start off with making our table. So our table, our first value is 0, 4. So that's right there, 0, 4. Our second one is -4, -4. Again, that's our second ordered pair. This is what these are known as, ordered pairs. Also coordinates for our grid. Our third is -2, 3. And our fourth is 4, 0. Now, if we look here, we don't have any of these x values repeating, so I'm just going to list them all again. So 0, -4, -2, and 4. And if we look at our y values, we don't have any of our y values repeating. So again, I'm going to list them all. 4, -4, 3, 0. And then we make a bubble out of this. And we also make a bubble out of this. So we're going to map. We're going to show where the x values go to for the y. So 0 goes to 4. 0 goes to 4. And we get that from our ordered pair. We also get that from our table. -4 goes to -4. -2 goes to 3. And 4 goes to 0. So here's our table. Here's our map. Now let's do our graph. So here would be our graph. So I'm going to start graphing out my points. My first point is 0 on the x, 4 on the y. So 1, 2, 3, 4. So I'm going to put a little point right there. My next one is at -4. So -4, -4. 1, 2, 3, 4. Put a point right there. Now, because of the device I'm using, it's hard for me to put a little point, so that's why I'm doing the X's. You would just put a point. For my third one, it's going to be at -2, 3. So -2, 3. And my fourth and last one is at 4, 0. 4, 0. So I've graphed it, I've put it on a table, and I've shown it as a map. So now what I'm going to do is I'm going to list all the domain values and all the range values. Your domain values are your x values. Your range values are your y values. So I can get those from the table, I can get those from the map, or I can get those from the graph domain. So the domain for this is 0, -4, -2, and 4. The range for this is all the y values. So that would be 4, -4, 3, and 0. Again, I can get it from the table, I can get it from the map, I can get it from the graph, or I can even pull it directly from these ordered pairs. Now, if I had something that repeated, I would not put it in here. So if I had, like, say 2 zeros, I'd only put one of the zeros in there because the domain value is just expressing all the x values that you use. The range is just expressing all the y values that you use. You don't need to repeat anything. So that would be example 1, showing it as a graph, as a table, as a map, and then determining what the domain and the range are. Let's take a look at example 2. So the graph represents the number of hours of a flight and the distance an airplane is from the ground. So we want to determine the independent and dependent variables of this relation, and then we want to describe what is happening in this graph. So let's start off with determining independent and dependent. So dependent, as it sounds like, needs the independent variable. So something is needed. So if we look here, the hours of the flight doesn't really need anything. It's just kind of doing what it does. The distance from the ground, well, it needs to know how many hours the flight has been going on to determine the distance from the ground. So our independent is our hours. Our dependent is going to be the distance from the ground. Distance from ground. Because we need the hours to determine how far away from the ground the plane is. If we didn't know the hours, we could not determine this. But we just need, the hours are independent. We don't really need anything for those. We could just give an hour and that's all we have to do. Now, let's describe what's happening in the graph. So the plane starts, so we look here, this is our starting point right here at the origin. As it starts, it goes further and further away from the ground before it finally levels off. So the plane starts going further away from the ground. Till it reaches its max height. And that's where it levels off right here. It then levels off. Then eventually it starts coming closer to the ground. The plane after some time let's space this out a little bit. After some time starts getting closer to the ground. To the ground until it lands. TIL. And that would be right here because the distance from the ground would be 0. So we've described the independent and the dependent, and then we described what is happening in the graph. So let's take a look at example 3. It says the following ordered pairs gives the length in feet and the weight in pounds of 5 snakes at the reptile house at a zoo. We want to graph the data. So let's start off with graphing the data. So the first one is 5.5 and 4.5. So we're going to come out here to 5.5. So that's going to be between 5 and 6. And then we're going to go up to 4.5. So 1, 2, 3, 4. 4.5 is going to be right in the middle of there. So we're going to put a point kind of in the middle of the grid. So I've graphed that one. I'm going to cross that out because I've already graphed it. The next one's going to be 3 and 0.5. So 1, 2, 3. Then 0.5 is going to be halfway between. So I graphed that. Then we have 3, 2, 3, 1, 2. Graph that. Then I'm going to graph this. Well, I end at 6, so I'm going to add 2 more. 7, 8. And then 4.5. 1, 2, 3, 4. 0.5 is going to be halfway between. So I've graphed that. And lastly, 2.5, and then 2, and 0.5 is going to be right there. So again, this one is just graphing out the points that we have. We build our graph and then we graph it out. If we really wanted to, we did not need to build a 4-quadrant graph. We could have just built a 1-quadrant graph because I see all the values are positive, and we know when all the values are positive, they are in the first quadrant. So we only needed a 1st-quadrant graph for this, but I put a 4-quadrant grid just to be safe, just in case. Let's take a look at example 4. So the height of an elevator above the ground is given in the table. Interpret the meaning of the axes. So that would be what is our x value and our y value. Our scale, that's how much the x is going by, how much the y is going by, and the origin of the corresponding graph and data. Origin, so right there, what does this mean? So if we look at this, the x value is going to be right here. That is time. If we look over at our table, time is our x. So x is the time. The time in elevator. So our y is going to be this point over here. Our y is going to be the height. Again, going back to independent, dependent. This is going to be our independent. This is going to be our dependent. We don't need to give it for this problem. I just wanted to refer back to it so you could see it again. Y is the height of elevator. And that's going to be in feet. Now let's look at our scales. So how much is it going by? Well, we got a mark here, then we got 2, a mark here, then we got 4. So while it looks like it's going by 2s, it's actually going by 1s. It just puts down the even numbers, because this would be 1, this would be 3, this would be 5, this would be 7. So this actually, the x scale goes by 1s. Now let's look at the y scale. Again, it's kind of tricking you again for the y. The y's got 20, 40, 60, 80, but there's a mark in between those. So the y is actually going by 10, 20, 30, 40, 50. Make that better looking 50. 50, 60, 70, 80, 90. So the y scale goes by, y scale goes by 10. So what does the origin mean? What does that initial point right here mean? That initial point in this means at 0 seconds, we have a height of 0. So at 0 seconds, we have a height of 0. Sometimes you might start off at a different floor. Say you had 2 elevators in this, and the first elevator started at the ground floor and the second elevator started at, say, floor 50. Then it could be 50 and then it'd go up from there. So in that case, it would say that it's 50. It's the start. But here it's 0, 0. So that's what our origin means. So we have 4 examples. Look through these 4 examples. Write a summary of everything that we've covered today right in this spot. And then after you've written your summary, go ahead and start working on your practice problems for today using these 4 examples as a guide.